All right. What a great talk, Sonia. To further delve into the possibilities of artificial intelligence in our daily lives, we ironically need to pull back on the deep digital realm and instead look to tangible real-world output. I'm excited to introduce our next guest speaker to discuss practical uses in artificial intelligence in manufacturing and robotics. Please welcome to the stage CTO of Acerta, Alan Tan. All right, Alan, welcome to the stage.
Thank you. Pleasure.
How are you doing this morning?
Great.
Awesome. Well, I'm excited to talk to you today a little bit more around manufacturing and artificial intelligence. But before we get started, maybe could you talk a little bit more about Acerta and what you guys are doing today?
Yeah, of course. We are a startup out of University of Waterloo engineering department. And our focus is to provide we call actionable insights to manufacturers, especially automotive manufacturing space. We believe that the modern engineering, especially a lot of Industry 4.0 digitization have already happened. However, there are lots of value hidden between those zeros and ones haven't been unearthed. Like you mentioned earlier, we're doing a lot of those boring and under the hood and sometimes oily shop floors, not the very bright visual and virtual world.
Okay, awesome. I know that one thing we were talking about a little bit backstage was this idea around the AI ecosystem. And the fact that the AI ecosystem is not such a new term. Do you want to talk a little bit about it from your perspective?
Yeah, exactly. Like you mentioned, AI ecosystem is actually not a new concept. Social media is actually a good, probably not so good example where we were actually the product, right? To be precise, it's our time and our effort. And our data has been mined, and AI algorithm actually was calculating how much value they can be sold to the advertisers. And then in turn, the algorithms actually try to figure out how to tie us tighter back into their platform. So it's more like a predator and we are the prey kind of ecosystem. In manufactured space, though, we look at it as a very different way to create this AI ecosystem. We have a lot of the equipment manufacturers already manufacturing digital equipment. Now, like I mentioned earlier, a lot of those data are used only locally, right? They haven't been pulled together. Now, if you think about modern manufacturing, you would see there are lots of different vendors providing those equipments, and usually they don't talk to each other. The data collected by one of the vendors, usually they're in different format and they represent different physical world information, and finding insights out of this holistic data pool is actually not one single party's job. So what we see that as an AI ecosystem is there are multiple participants. Each one of them play a role in this collaboration, but they all evolve, right? They're impacted by each other. And so in our case, for example, we believe that the current biggest gap is in the holistic view of all the data points that I have on my shop floor. And we do already see the opportunities for example, the IoT sensor side. I'll give you probably a boring example that there's still lots of IoT sensors that currently send you things like 999 or 32768. They are actually error codes. They're actually not representing either torque or temperature. Those were actually Industry 3.0 days where they call them smart numbers. They use a special numeric value to represent a special status. They're actually pretty bad for machine learning models, because if your temperature sensor sends me something like 999, if I don't know what that is and I put it into my AI models, it actually skew the outcome significantly. And with more and more AI models started to leveraging those,
Yeah.
it provides incentive for the IoT sensor manufacturers to start making those changes. No longer use those 999s as error status indications, for example. On the other hand, we also have seen that the user community, the operators who have been working on the lines, they are become more and more data savvy.
Yeah.
And however, the AI has been something that especially the operators on the lines tried to shy away, right? So when you're talking about manufacturing, we are talking about the people who actually have more than 8 hours work already. They don't have time to sit down in front of computer screens to drill down of those fancy charts, etc. Right? So to be able to get the AI's insights into their hands, it needs to be something that relevant to their daily job.
Yeah.
And that actually is another area where we found we needed to work with them, not just dump something super fancy on their plate and then say, hey, from now on, in addition to your 8-hour work, you need to look into this and making sure you drill down 10 steps and find this insight.
Yeah, and I think you bring up a really good point too. Actually, one of my first jobs when I was in my undergrad was actually working on a manufacturing line. And so we were building car seats for Chrysler. And that same sort of thing you were talking about is you don't really have time to sit in front of the computer because it's just-in-time inventory, everything's coming down, and if you're like, oh, by the way, I need you to look at this, and we're still testing it, and it's like, does this actually make sense to help you in your job, are kind of two very different things, and it's kind of hard to change that behavior if it doesn't necessarily result in like a certain sort of outcome. And so when we're talking about manufacturing and we're talking about robotics, one of the biggest things is like, robots are here to take my job. We've all seen I Am Legend, but that's very much not the case, especially when we're looking at manufacturing and even in large enterprises. A lot of the times AI is there to kind of help you make a better decision and to help kind of provide you that information. So when we're coming full circle around this idea with human-friendly AI, can you talk a little bit about automation and maybe that automation isn't something that we're really looking to do?
Yeah. Well, actually, Industry 4.0 already automated a lot of things. As you know, the modern manufacturing space, we usually remind ourselves, manufacturing is not a low-tech business, right? So we sometimes we pride ourselves, we do AI, we're high-tech.
Yeah.
Manufacturing is actually not low-tech. There were lots of innovations went into the manufacturing process in the past several decades. So they're fairly sophisticated. Now, where we believe that the AI can play a better role is not to replace the humans on those automation lines. Instead, it's a collective system where human, machinery, and AI models working together that can produce more value. This is actually an interesting way of looking at it. We know that artificial intelligence is human try to produce a sort of intelligence, right? And the most obvious yardstick is actually human intelligence. So we often evaluate the success of AI by comparing them to human intelligence. It worked really well in academic settings, right? In doing research. But when AI started to be put into practical use in the wild, some of those kind of comparison spilled over, right? Yeah. Meaning that from a business perspective, it becomes very, very common justification to say, hey, if I invest in this AI solution, how many people can I cut? And that actually is not what we believe the best use of AI. This is back to something that we talked about in backstage, that there is some very intellectual work that AI can do well, right? Playing chess, for example. We conquered that back in 1997. And there are also some fairly low-end things that can be automated. A lot of the machineries, they don't even need AI, right? So some of the automation happened even before digitization. But there are a huge gap in between that are very hard for machinery and AI to conquer. Now, when we did some research, it turns out that once we have perfect digital twins, right, the AI model usually works really well. Now, if you think about playing chess, for example, all the rules are actually set. You have 100% matching of the digital rules versus whatever the game rule is. So that actually makes AI, coming home, right? So they feel home. Now, in manufacturing, we are producing physical goods, right? So to create those digital twins, it's actually a much harder to accomplish things for any technology. Meaning that any moving parts, if I need to capture the status of those moving parts, that probably will generate super high level amount of data, and most of them probably will be useless. However, this is not a challenge of human. Human can actually model the real world really, really fast, really, really easily. And even though their calculation, once they create those models, are not as fast and effective as AI, but they can model it really well. So people can actually handle rare scene events much better than AI. Now, in our example, when we were helping our customers to improve their yield, the first pass rate, from somewhere in the mid-80s to somewhere in the high 90s, it was relatively easy.
Yeah.
Once we go beyond that, for the data scientists in the room, they probably know that a data set starts to become biased towards the good parts, and most of the failures become rare happen events. It's much harder to predict.
Yeah, absolutely. And so I think that's kind of interesting when we're looking at human-friendly AI and the role that humans actually play in kind of closing the loop and being an active player in the ecosystem. One thing that we talked about too in the back, sorry, we're referencing all these conversations we had in the back, was just about this idea of understandability. And so when you're putting a model in front of someone, what is the chance that they're actually going to use it? And I think you gave a really good use case of like where that's working well and where that might not be working well.
Yeah, that's right. We actually emphasis on the understandability over the explainability, because we see that as a two-way traffic, right? So not only just being able to explain what our model predicted and the rationale to another data scientist, but understandable by people who are working on the production line who didn't have an opportunity to get a PhD in statistics. We actually run into that situation. Very interestingly, we actually had this model to help one of our customers to predict. In their final assembly, they needed to put something like a washer into their final assembly. There are hundreds of different types of washers, different size. And usually it's an experienced operator to make those choices, right? So which one out of the hundreds they should put into it. Our early attempt, actually, we worked on deep learning models. And the model worked really, really well, way much better than what operator does. However, as we probably all know, that a deep learning models, it's fairly hard for normal people to understand. And once we put our solution on the shop floor, as soon as we make one mistake, the operator will turn our system off, saying that this is crap. And now, first, well, you can guess we were probably a little bit pissed. But after some, soul searching, and we look at it, it actually makes sense. Because if the operator understands something, they would be able to add on top of what they think they understand and their intuition, right? So if they say that, hey, the system looked at whatever the gaps that it found and recommended this size of the washer, and I actually happen to know something more than that, right? Whether or not this batch of assembled parts is going to a particular model, and I want to make slight adjustments on top of that. So in that case, you're seeing the AI's solution become something that can be work together with the user input. Now, if they don't understand it, on the other hand, it becomes an either or, right? Like they either have to blindly trust whatever that the AI says, or like in our case, they just turn it off. So we actually ended up delivered a dumped down version of our solution. It actually uses some input that the operators actually can understand. And actually, it worked much better. It's the end result. The human plus our new model together worked much better. But if you only took our second model compared to our first one, the performance was actually worse.
That's interesting. And I think that's really good learning from the audience, or kind of a lesson for the audience, just in terms of that interaction together. And it's the same sort of thing NVIDIA was even talking about, and Sonia, is just like, how do you have those interactions together? And maybe you don't need to fully bake something and make it perfect before you're actually testing it, because once it's in the wild, you don't know what's going to happen. You don't know about the interactions.
Yeah.
And then, so, we're talking about the AI ecosystem, we're talking about human-friendly AI, we're talking about the understandability and explainability. Maybe to kind of end with a fun question, what is the book that you have been gifted the most throughout your career?
One of the classic for probably all data scientists is actually Darrell Huff's How to Lie with Statistics. We found it's really, really insightful. Not just learning how to lie, but it has a lot of early insights into how humans perceive various different data, how technically accurate statistics may not resonate with people, and they actually probably will take information out of the context. And that actually gives us a lot of the insights of how to avoid misleading people, and then how also work with the individuals. And actually, as a matter of fact, at Acerta, we're spending more and more of our R&D effort on researching human, so how humans interact with AI, in addition to just AI models.
Okay, awesome. Well, thank you so much for your time today, Alan.
My
It was
pleasure.
great to hear from you and your experiences. And we'll be on shortly with our next talk.
Yeah, thank you for your questions.